This is an equation with y on both sides. I'm going to go through it the way that I teach it, and then I'll give an alternative explanation. So actually maybe two alternative explanations. What we need to do here basically is get it so that y is on one side, and we can do that by using the balancing method and minus 3y from both sides. It's best to minus the smaller of the y's rather than minusing 5y. So we get 14 equals 2y plus 1. We then minus 1 from both sides. We're now at a two-step equation essentially. So this is going to give 13 equals 2y. And then I divide through by 2. And y is equal to 13 over 2. And that should be an absolutely valid answer. You could write it as a mixed number, which is 6.5 or 6.5, but any of those are okay. Another way you could have done this would be to have kind of done it visually using a bar model. So this will explain the steps I just did above. 3y, and then I've got 14, which I'm going to write as 13 and 1, and that's equal to 5 lots of y so they're balanced essentially, and then what I've done is got rid of a y from both, one at a time, and that is the same as me minusing 3y. So I'm left with 14 equals 2y plus 1. I actually forgot about the 1, sorry. So what we can then do is cancel out the 1's because they're balanced, and that leaves me 2y equals 13. I just then need to split it. One way that I have seen people solve this is to realize that the difference between these two and y's is 2y, and the difference between these is, well, minus 13. And then people have gone straight to writing this down, but make sure you have this approach sorted ultimately, because it's needed for more complicated equations with minuses in as well, and so on.